Hello, I'm Jagan from Grow with Data. Welcome to the Crack SQL Interview in 50 question series. In this video series, we'll practice 50 SQL questions across various topics. You can use the playlist Crack SQL Interview 50 questions to follow the videos related to this series. For each video in the series, you can find the related code on my GitHub. Feel free to explore the code and provide any feedback in the comment section. If you go to the YouTube Grow with Data playlist, you can see the Crack SQL Interview 50 questions playlist. If you want to go with any other particular video, you can just click on it, and to get the code, you can go to the description part, and then you can see the code GitHub link, and it will take you to the GitHub page where you can see the create script and all the select statement we discussed in that video. If you want to join in the WhatsApp channel or Grow with Data, you can use this link and you can join the WhatsApp channel. Okay, now let's dive into the 19th video of the series, and we are going to continue with the basic aggregation function. Let's see the data and we can talk about the question in detail. We are given the table queries which got a query name, the result, and the position. We have a rating. So what we did is we took the 500, the top 500 SQL, and we positioned that from 1 to 500, and we give the rating. So rating is from 1 to 5. If the rating is less than 3, if it's 1 or 2, that means it's a bad query. If 3, 4, or 5, it's kind of okay. 5 is good and 3 is average, 4 is but good, 5 is better, we can say, right? So 1 and 2 are poor queries. And we are defining two calculations. The first one is the query quality. So the quality of the query is based on the average of the ratio between the query rating and the position. So the rating by position will give you the query quality ratio, and you take the average of it. And the second one is poor quality percentage. As I said, if the rating is 1 or 2, right? So it's a poor query. So the percentage of the poor query is the sum of queries, which is 1 or 2 divided by the total number of queries. That will give you the percentage. So we have to write a solution to find for each query name, like here we have dog and cat, right? So each query name, you find the quality and the poor query percentage. The query name doesn't exist. If there is a null query name, then you just ignore those queries. So both the quality and the poor query percentage should be at 2 decimal place, and we can return the results in any order. It can be the query percentage and the quality or the query name, however you want to order it. So the output has to be like this. We have to give the query name, the quality, and poor quality percentage, and all are in the 2 decimal places. Okay, let's comment this out, and we can start with our basic things. So in a previous video, we tried the CTE table, and then we tried subquery tables, right? So let's try a subquery table. How will you do it? The first thing is we have to find the ratio and the percentage part of it. Let's start with that. Select from queries, right? So for every query name, we need the quality. The quality is nothing but the ratio between the query rating and its position. That means rating by position is equal to quality. And the poor SQL. How will you find the poor SQL? You can use a case statement or a if statement. I use with case when the rating is less than 3. It's not less than or equal to, it says less than 3. Then we consider the 1, else 0 end as poor query. Let's run this code and check. So if you see the dog, we have 3 parts, right? So if you want to see the ratio, it's 5 by 1 is the quality. So 5 by 2 is 2.5. 1 by 200 is 0.005, and then 2 by 5, we get the quality ratio. And for every query name, for dog, we have 3 queries and only one is bad query, which is less than 3. So we got 1. So the total quality percentage should be 1 divided by 3. Same with cat. So only one query is below 3. So 1 divided by 3 will give the quality percentage. So 1 by 3 is 0.33, right? So percentage wise, it's 33%. So how will we do that? So here we just take the average of the ratio as quality, and this one I take the sum of all the poor query divided by total count. So I simply say count star as the total queries. Since we use aggregation, we use group by 1. We have this data. So 1 is the query name. When you run this, you get the, for every query name, you have the quality and the poor query, 0.33. We have to make this as percentage. For percentage, we just multiply by 100. This multiply by 100 can be in this position also. Since we saw the last video, the precedence is same for multiplication and division. Wherever you put in, it doesn't make any difference. If you do parenthesis, then it makes a different story, right? Okay. So now we got the query name, quality, and the percentage. So the next one is we have to round that to 2 decimal places. How will you do that? Use the round function, comma 2. Round, comma 2. Good. So we address the ratio part of it, and then order by doesn't matter. The main thing is if the query name doesn't exist, then you ignore it. So here we don't have any null value. Let's try to insert a null value for the query name and see how the query behaves. So I have another query set which has a null. So our query doesn't filter out the null. Okay, let's comment this out. And how will you fix our code? So when you say null, you say where query name is, we don't want the null, so not null. When you run this, it will filter out the null value. So we have where class and we have having class, right? So what will happen if you say the query name, having query name, so what will happen if you do this? The same part of it, because the aggregation part, it will handle all this, right? So what is the difference between the where class and you have the having class? For example, I want to consider query where the quality percentage is greater than 2, right? So when you say the query or the quality is greater than 2.5, means 2, we have to consider only 2.5, right? This has to be filtered out. I can't use this condition. Let's try this. I can't say where the quality, okay, let's say, and quality is greater than 2. If I say and quality greater than 2, it will throw me an error because quality is an aggregation function, right? So where class will do at the row level. For every row, it will go and check if the query name is null or not. So if I want to do some calculation which involves the aggregation column, then we have to use having the quality greater than 2. Now it will filter out the second record, which is 0.6, right? The cat one will be filtered out. So the having part has to come after the group by, because having will always work on the aggregation column. But the where class is not like that. The where will work at the row level by detailed, right? So every row, it will just trigger the filter and check if it's right or wrong. If it's wrong, it will filter it out. And when you do the null value, you can't say where the query name equal to null, right? When you say equal to null, it will just throw a empty thing, right? So because null is not equal to any value, so you always say is null or is not null. You can't equate a null value with like null equal to 5 or null equal to 6, right? We can't compare null with any equal value. So we always say is null or is not null. Okay. So this is the simplest version of the code. So we just have only one table call, and then we use the aggregation function and the overall count, and we get the percentage part of it. Remember in the last exercise, we tried a subquery table and then we tried CTE table. Let's see how we might have done this in the subquery table. Okay. So first we try select this part, the query name and the average part, and we don't do the round one now. Okay. So this will give the quality ratio, and this one give the poor query. Okay. So group by one. Since we use average and sum, we need group by one. So this will give for every query what is the quality ratio and the sum of the poor query. This we use as one table. Okay. So this one we keep as one subquery table from where group by this. So we consider this, and then the overall part, inner join select query name count star as total query, same from the queries group by one. So here we get the total query count based on the query name, and we have the filter where query name is not null. Okay, this one we say as total, this one we say as base, and we use this and say select b dot query name and b dot quality, and then b dot poor query divided by t dot total query from this table. And how will you connect this two table? Remember, we just say on one equal to one, but here we have the query name as the connection point. Query name equal to b dot query name. So here, we have to get the column name as percentage poor query percentage. So we round this up to 2, and we round this up to 2, and we got the answer, the query name, quality, and the percentage. And you'll do 100 because it's a percentage part into 100, right? So what will happen if you remove the 0.00? No difference. Okay. So you put 100, so we get the poor query percentage. So now if you see, we have one query to get the normal calculation, the second one for the total, and then we use that for the normal thing. So now if you see sum of, instead of average, if you do sum of, then we can say b dot quality divided by t dot total query. Oh, is a position, right? Sum by average, right? So total. So instead of average, if you want to do sum, then you divide that by total query to get the quality percentage. So if you see this query first, then you think this will be easier, right? You have 2 steps and then you're calculating it. But after knowing that you can do a simpler version of it, how will you feel if you see this query after knowing that we can do it in a simple version of it? It's weird, right? So whenever you get a question, better you understand the question clearly and see how we are going to approach, then you step into the writing the code. If you just jump into the code after seeing the question, then you'll end up doing a SQL like this. This is not a wrong way of doing it, but again, it's not the best way of getting the code. So this might be the right way of doing it, and you'll get it only when you focus on understanding the question, and then you step in and see how we are going to proceed, then you do the code. Okay, if not, then the second option might be your output. Hope you like this video, and thanks for watching.